finding the length of chords within a circle, and so this is why it's important to know what these terms mean, so you know what a chord is, you know what you're looking for, and we'll work through this problem together. Okay, so the first thing to notice is we're trying to work out what this chord is, yep, the length of this chord. Everybody's cool with that, yep, because this is the chord, it's XY, we need to work out its length. We have a triangle here. Does anybody know what type of triangle this is? Yep, Grayson?
I believe it's equilateral.
It's not equilateral. Okay, well, what is an equilateral triangle? All sides are the same. So if it's, how do we don't know that all the sides are the same. What are all the angles in an equilateral triangle? They're all 60, so this can't be an equilateral. It is a, Grayson?
Isosceles.
It's an isosceles. How do you know it's an isosceles triangle?
Because the top angle is 30.
This one?
Yeah.
We got, this one's 30.
Yeah.
Okay, so this is 30, yeah, but...
And the other side would be 6. Oh, because the radiuses are the same way.
Right, good. This side has to be 6 centimeters because that is also one of the radiuses, yep. These are both radiuses, so they're both the same length, yep. So that means it has to be an isosceles triangle, okay? So what I'm going to do is I'm going to redraw it. Okay, I'm going to make it a bit bigger. I'm just going to draw the triangle. The isosceles. Alright, and I'm going to label, so this is 6, this is 6, this is X, this is Y, this is O, and this is 30 degrees. Okay, all good so far? Yeah. Alright, so I've just redrawn it. Now, if I take a line, I don't know how I change the color of these lines, it's quite annoying. Okay, and if I cut straight the way through this angle, so it meets our chord at right angles. What is it doing to XY? It splits it in. It's going to split it in half. Right, okay, so these two sides are going to be the same. From here to here and here to here are going to be the same. Grayson, stop writing. Watching. Okay, I want everybody watching. Damon. Alright, now if I've cut this angle in half, what is then this part? Yeah, that has to be 15 degrees. Okay. Okay, I could work out this angle if I wanted. Right, good. But now what I've got is, I'm going to draw another triangle. It is a right angle triangle, and that is important because, so we're saying this is 15. Why is it important that it's a right angle triangle? Yeah, it's easy. We can solve it using trigonometry. Right, good. So this is the side that we want to work out. Right, so how could we work out the length of this side? Doing trig, so what's the first thing we do?
Label your sides.
Label our sides, okay. So this side is the,
Opposite.
good, because it's opposite angle. This side is the hypotenuse, and we know that this is 6 centimeters. This is the adjacent, okay. Alright, so what do we know and what are we trying to work out?
We
Trying to work out the opposite.
Yep, opposite and adjacent, so that means I am going to use sine. Right, good. Just going back to our SOHCAHTOA, we know the hypotenuse, we want to work out the opposite, so it has to be sine. Right, the formula is sine of the angle equals...
Over 8.
Yep, opposite over hypotenuse, good. What is the angle we're using?
15.
15, good. And the opposite is what we don't know. We'll call it xm, okay, over 6. So how do I work out what xm is?
Multiply sine 15 by 6.
All right, good. Sine 15 multiplied by 6, which is 1.5529 centimeters. All right, so this distance from here to here is 1.5529 centimeters. Let me just move this up a bit. Am I finished?
Now multiply that by 2.
Right, I have to multiply it by 2 because this is 1.5529. This is 1.5529. Sorry, apologies. 1.5529. So xy is equal to 2 times 1.5529. Which is 3.11. Does that make sense? We did a lot of trig last year, okay? And we did ones where like this, where we had isosceles and we had to split them, okay? The important thing is making it into a right angle triangle so you can use trigonometry, okay? And you're cutting it smack bang in half, okay? You're cutting the side in half, you're cutting the angle in half, okay? And then you don't forget to multiply your side by 2 to work out the total distance of the chord. Make sense?
Yeah.
All right, good. Let's get it copied.